Okay, we want to go ahead and do some examples from Chapter 1, Lesson 2. I've got 5 examples here. All of them are evaluating problems or simplifying problems. And we should remember that when we talked about this, the difference between evaluating and simplifying. And we'll talk about this as we go through, but remember, evaluating means that you take numbers and you substitute them into an algebraic expression that has variables in it, and then you go ahead and simplify that expression down. To simplify an expression means you just simply go through and add up any like terms that you can using the properties of arithmetic, distributive property, adding like terms, and those things. So let's do a few examples. So I have the first one here set up where I have an algebraic expression, and we notice that it has some variables, some x's and y's, and it says to evaluate. Instructions over here. So the x value is going to be a 7, and for every y we're going to put in -7. And remember, we talked about trying to help ourselves not make the mathematical errors that lead to problems and getting things wrong. And one of the things we want to do is we want to go through and rewrite this algebraic expression, and for every variable, for every letter, I'm going to put a parentheses there. I'm not going to put anything in it. I'm just going to write the parentheses, and then I'm going to go back and substitute in the values for each letter. Doing that, you remember, will help us avoid making some little mistakes, losing negative signs, forgetting a negative sign. And so this will kind of help us and protect us from doing that. So I'm going to go ahead and rewrite this expression. So I have -5, and then parentheses, and I have an x here, so I'm going to put another parentheses for the x, plus 2 times a parentheses for the y, and then I have this parentheses here, plus 15, and then I have the parentheses, I have an x, plus 2 times another letter y, and then I close it off. So all I did was I copied the expression that we have, but instead of writing letters, I wrote a parentheses for each letter. Now I'm going to go back and into each parentheses, go ahead and substitute in the value that they gave me for that particular letter. So here, x. X, they tell me over here, is going to be a 7. So for every x, I'm going to put in 7. So for this x right here, goes a 7. For this x over here, goes a 7. And then y, as we notice over here, y, well, let's use a little bit different color than that. I'll get one. Y is going to be -7. So for this y here, I'm going to put in -7. And for this y here, I'm going to put in -7. So by doing this, we rewrote the expression, and now we've substituted in. Now we go ahead and do the evaluating. Again, we're going to use PEMDAS. We're going to do parentheses first, any exponents, and then we can multiply, divide, add, and subtract. So inside the parentheses here, I have some work inside the parentheses here. So I have -5, then I have this 7, and then I have a +2 times a -7, which is -14. 15, and then I have, again, a 7, and then here I have +2 times this -7 is -14. So I went ahead and did that little distributing inside there. Now I'm going to go ahead and to simplify these with inside here. So 7 minus 14 is -7, plus 15, and then 7 minus 14 here again is -7. Then I go ahead and multiply these two numbers together. So a -5 times a -7 is a +35. Two negatives make a positive. And 15 times 7 here, it's a negative. A positive times a negative, so it's a -105. Now that I've taken care of all that, I have one last step here. I can go ahead and add these together. So 35 minus 75 ends up being -70. So -70 would be the evaluated answer for the x value of 7 and a y value of -7. Okay? All right, let's take a look at another example. On this page, I'm asked to determine the perimeter. And perimeter is a word we should become very familiar with. It means the distance around an object. And so imagine if this was a park and you were standing here and you were going to walk around the park. Okay? And you would begin here and you would walk, let's see, you would walk up this way. Let me get a good color that I can get here. Here. So you would walk up this way first, okay? And you walk all the way along that. And then you would walk over here. And then you would walk up this way. And then you would walk over here. And then you would walk down here. And then you would walk here. if you did all that, how far would you walk? You notice it's a distance around. And when we want to know how far all these distances are together, well, we recognize that that would be an addition problem. So something you want to just remember with perimeter is perimeter means add the sides. So you just simply take all the sides and you add them together. So let's go ahead and do that. So if I started right here and I walked up first, I would go how far? Well, I would go A minus B. Plus, then I walked here, how far? Well, that's B. Plus, then I walked up B. Plus, then I walked this way, A minus B. Plus, then I walked A. Plus, and then I walked A. So the perimeter again is an addition problem. And so I simply add all these together. So now what you see we have an algebraic expression where we want to just simplify it. So we want to add all the like terms. So I want to go through here, and I can get rid of these parentheses again by putting a 1 in front and distributing. So this is going to be A minus B, then plus B, plus I distribute a 1 here, A minus B, plus A, plus A. Then I can go ahead and add like terms. So I want to find all the A's. So here's 1A, and here's 2 A's, 3 A's, 4 A's. So 4 A's is equal to 4A. And then here I have a negative B plus a B. Well, that's going to be 0. They're going to cancel out. Negative B plus B is 0. So that's 0. Then I have B minus B. Again, that's B minus B. That's 0 as well. So I end up with 4A plus 0 B's, if you want to write it, or 0, and 4A plus 0 is simply 4A. Okay, so the perimeter of this figure would be 4A. And again, get comfortable in working with letters like that. You know, when you're adding things together, it doesn't always have to be numbers. We can work with letters because, as we've talked about, letters are just symbols, just like numbers. Okay, now this little step that I showed you, this whole 0B thing, just to show you why it's 0. If you recognize that B minus B is 0, that's fine. You can just go ahead and add that together. All right. Let's look at the next example that I have here. And there we go. And here we have our asked to evaluate, and B is going to be -1, and we have absolute value. And again, we treat absolute values almost exactly like parentheses. There are a couple things we can do with parentheses that we can't do with absolute value, but we won't worry about that right now. But as far as when to do what, as far as order of operations, you want to work inside absolute value first, just like you would parentheses. So we're going to rewrite this expression, making a parentheses for each letter, and then go back and substitute in the value of that letter. So I have 6 times the absolute of 4 times a B value, minus 5, plus 3 times 2 minus 2 times a B value, absolute value. So again, I rewrote it, and for every letter I wrote a parentheses. Now, it tells me that for every B, B is going to be -1, so for every B, I'm going to put in -1, and I'm going to put in -1. Now that I've done this, I can go ahead back and go ahead and simplify, again, like parentheses inside here. So I have 6. I have 4 times -1, which is -4, minus 5, plus 3 times 2, and then -2 times -1 is a positive 2. Right? So simplify in here, so this is going to be -9, plus 3 times 2 plus 2 is 4. Okay, now here's something very important, and I have another video on this. Make sure you check out the absolute error video to understand what I'm going to do here. The tendency here is you can't distribute into absolute value signs like you can parentheses. That's why I said that working with absolute values is almost like parentheses, but not quite. And this is one of those cases. You can't distribute into parentheses. The absolute value, remember, is a distance from 0, so we have to take that absolute value first. So it's 6 times the absolute value of -9, or how far is -9 from 0? 9. Plus 3 times the absolute value of 4. How far is 4 from 0? 4. Okay, so take note of this step and watch that other video for some clarification if you're not sure what I did there. 6 times 9 then is 54, plus 3 times 4 is 12, so adding those together I get a nice root 66. Alright, So 66 would be this expression evaluated with b as negative 1. All right, another example. Okay, here we're just asked to simplify, and simplify, remember, means what? We distribute if we can and then add like terms, so we need to go ahead and do that. So we're going to multiply because of the parentheses, we're going to distribute. So a half, we multiply it times this, I get 1/2 x squared. And then a half times this negative y gives me negative 1/2 y squared. Then when we're distributing this negative sign goes with this, so negative 5/2 times x squared is a negative 5/2 x squared. And then this negative times this negative is positive, so it's going to be a positive 5/2 y squared. Okay, so we distribute it. Remember, simplifying means we're going to look for like terms and add them. So if I look closely here, what makes things like terms? We have the exact same variable and the exact same power. So here's an x squared, and here's an x squared, so I can go ahead and add these coefficients. All right, the x squared is going to be there. That's just what makes them like. We just want to go ahead and add these. So 1/2 minus 5/2 is negative 4/2. And then we want to look, and I see here's a y squared, and here's a y squared, so I've got something y squared. Again, to add those, I add the coefficient. Negative 1/2 plus 5/2 is a positive 4/2. Okay, so that's simplified. I can't do anything more. But remember, we talked about there's one last thing that's not really simplifying. It can be, but it's called a matter of convention. And as a matter of convention, or things that we do all the time in mathematics, for our final answer, we never give a fraction that's not simplified or reduced. Okay, so I have to do this every single time I have any kind of problem with fractions in it. I have to make sure that I reduce my final answer. As I look here, I notice that negative 4/2 is actually reduces to negative 2, so I have negative 2x squared, and then 4/2 here again reduces to 2. So I have 2y squared. There aren't any more like terms, so this would be my simplified expression. Okay, and then finally here we have one more. It asks us to evaluate, and remember, evaluate means to substitute in a value and then simplify the expression. And then again, to protect ourselves, we're going to rewrite the expression, and for each parentheses, or for each letter, I'm going to put a parentheses. Okay, so the -2, and then here's an x minus 3, and all of that is over an x plus 6. Then I'm going to go back and substitute in the value that they give me for x. For every x, they want me to put in negative 3. So for this x, I'm going to put in negative 3. For this x, negative 3. For this x, negative 3. Now that I've substituted in, I can go ahead and simplify this. Okay, again using my order of operations. So I've got a 3, and then I got 2 times negative 3, which is negative 6 plus 1, minus 2, and then this is just going to be negative 3 minus 3, all of that over negative 3 plus 6. Okay, then I'm going to go ahead and work inside the parentheses here. So it's 3 times, when I add these together, I'm going to get negative 5. Minus 2 times, I add these parentheses together, I get negative 6. All of that, negative 3, all of that over negative 3 plus 6, which is 3. Okay, then I can go ahead and distribute this 3, so that's negative 15. Negative 2 times negative 6 is positive 12 over 3. I can go ahead and add these two up here, so I have negative 3 over 3. These reduce to 1, leaving me an answer of negative 1. So negative 1 would be my evaluated version of that problem. Okay, I think that's all I have, and so hopefully that's been helpful to you, and good luck with your homework, and we'll see you in class.